well, glad you were. Doing so, you. All right, well, here I am. You can start.
Okay, let's get started. Let me have your attention, please. Let's get started. Welcome to the University of Tennessee Nuclear Engineering Department Colloquium Program. My name is Lee Dodge, and it's my privilege to introduce today's speaker, who is Mr. Dennis Ruddy. He is the President and General Manager of the BWX Y-12 plant, which is part of the National Nuclear Security Administration. Denny received a bachelor's degree from the Polytechnical Institute of New York in Brooklyn and a master's degree from NYU, both degrees in metallurgical engineering. He has 30 years of experience managing complex nuclear and non-nuclear manufacturing operations, which includes 25 years at DOE's Bettis Atomic Power Laboratory. Prior to arriving at Y-12, he was the president and general manager of the BWXT Pantax plant in Amarillo, Texas. It's indeed a privilege to have Denny with us today. He's right 30 miles away, and he has lots of jobs for young people, and we're so pleased that he's here today. So please welcome Mr. Denny Ruddy.
Can't get a better introduction than that at a college. You have plenty of jobs. I was trying to remember when I was in your position, and I hate to tell you that 30 years is kind of a low estimate. That part of that resume was written a few years back, but my graduation year from Brooklyn Poly was 1967, so I was trying to put myself back into the colloquia that we had as part of the metallurgy department, and remember all the people hustling, the folks that came in from industry and trying to give them resumes and get business cards from them. So I remember what that's all about, and I was one of the fortunate ones. I had been a co-op student, so I knew where I was going to work, so I could concentrate a little bit more on my studies during the season than some of the anxiety that I know you're all going through right now. But the good news is we are hiring. We're hiring a lot of engineers, and as I was mentioning to one of you just before we started, this is a pretty good time to be a nuclear engineer. I entered the business, the nuclear business, in 1969, and it was probably the last point where we had what you might call uninformed enthusiasm about the nuclear industry. It was just before the nuclear industry got itself into a little bit of trouble. I worked for Westinghouse at the time, and you might remember back then, some of you with the gray at your temples might remember that Westinghouse was selling uranium futures at the time, and it wasn't a real good time generally. I worked for Westinghouse when we canceled about 30 barge reactors that we were going to build for the nuclear industry, and the sky was the limit in the late 60s. Unfortunately, the early 70s saw a change in the attitudes toward things nuclear, and it was a pretty tough time. But we're back now at the end of the Dark Ages and at the beginning of the Renaissance from a nuclear engineering standpoint. We see in the newspapers TA is actively starting up reactors and extending the life of reactors. The Naval Nuclear Program is alive and well and has been the place where most of us went and hid for the 25 or so years during the darkest times. And organizations like Y-12 and Oak Ridge National Laboratory, Los Alamos, and a lot of other places are continuing the weapons side of the nuclear business. So it's a good time to be a nuclear engineer. You picked well, and I think your career choices will be rewarded. Y-12 is probably the least understood of the Oak Ridge treasures. It is the place where the Manhattan Project started in 1943. There had been work at the University of Chicago. There had been work all over the country, but when we really started the Manhattan Project, the first dirt that was turned over for future construction to support that massive engineering effort in this country was right in the valley and right at the site where Y-12 is located today, and that was February of 1943. So the history of Y-12 goes back to February 1943, and last year we celebrated for our 60th birthday, and it was quite an occasion for us. It gave us an opportunity to look back at the accomplishments of the Y-12 complex over that time, the changing missions, and I'll review a little bit what they were and where we are today and where we're going in the future. And certainly attracting new engineering talent and changing the mix of the people at the Y-12 reservation is an important thing for us. And nuclear engineering, materials engineering, mechanical, we use just about any kind of engineer that they used to drive a train. But we really do need new talent coming in. We need experienced talent to replace some of the people that move on and make other career choices. But we will be using a lot of new engineers. And as a matter of fact, there's at least one of you in the room, and maybe two since we got organized, that have already accepted positions out at Y-12. So we're pretty happy about where we're going in our relationship with the University of Tennessee. Just briefly, the history started, one of the biggest challenges, as it's been in every armed conflict that the United States has been involved in, was turning our commercial strength, our industrial strength, toward the materiel that's needed for war. And in the Second World War, after we supplied most of the conventional weapons, it became clear that an early end to the conflict would come again from our industrial might, and that was in the manufacture of nuclear weapons. The Y-12 was the place that we first did the separation of uranium-235, fissionable uranium, from natural uranium, and as probably most of you know from your studies, the first processes that we used were the calutron processes, the magnetic separation of ionized uranium, and then that material was feeder material for the fusion process, which originally was done at the K-25 site, another Oak Ridge reservation, and later on in Paducah, Kentucky, and in Portsmouth, Ohio, with very large commercial separation plants. In addition, the uranium that went into the reactors that was eventually converted into plutonium also started at Y-12, and so our history started by the enrichment of uranium. When that moved on to more commercial-sized ventures, then the attention shifted at Y-12 to the manufacture of enriched uranium parts and other parts to make what are called nuclear secondaries, or the parts that convert an atomic weapon into a thermonuclear device. And that has been our mission ever since, our fundamental weapons mission. Today, as many of you know, we don't build any weapons at all. What we do is we are the caretakers of a stockpile of weapons that reached its peak in the middle 80s. And that stockpile at that time was about 25,000 weapons. Today our stockpile is less than 20% of that. And so our mission is to keep that stockpile ready for use if, unfortunately, we would ever have to use it, to make sure technically it represents the deterrence that we want, because that's our peacekeeping mission, the United States and specifically Y-12. And finally, to make sure that we monitor the materials in those weapons to look for deterioration. And so our weapons mission today is to perform surveillance on the stockpile, where we bring in weapons periodically of every type, and we look for the deterioration and the usability of those weapons. That forces us to take some of the parts out of the stockpile and actually destroy them in doing our testing, and then we remanufacture those parts to return those weapons to the stockpile. In addition, we do testing which actually, what we call flies the weapons. We actually put them on a delivery platform. We take some of the nuclear materials out of them, but we fly those weapons to make sure that they still have the integrity that they need to be delivered. And then finally, occasionally we'll find a material defect or we'll find some aging effect, and what we do then is we get into what we call a life extension program, which is to remanufacture a part or a number of parts of the weapon and put them back into service. What that means is we have to maintain a manufacturing capability that has all the capabilities that we had during the heyday of the Cold War, but we also are manufacturing at much less volume. And that makes us more and more dependent on engineering rather than just the craftsmanship that was used for most of the time during the manufacture of the weapons. When you manufacture something day in and day out, you have a collective or tribal memory that helps you day to day. But when you do it infrequently, when you stop it and start it, the engineered side of the processes and the engineered side of the protective systems have to be much more robust, and that is the way the nature of our business for weapons has changed over time. This represents to us the way our mission is divided. I mentioned a lot about the history and the current state of our mission relative to the defense programs or the weapons programs. But a spin-off business, and especially in the post-9/11 world, is using some of the technology that we use in security and protecting our materials to also convert them, kind of turn them inside out, to come up with ways of detecting nuclear material transport around the world, to develop forensics for when we go into other countries and we want to see if they've had nuclear programs of one kind or another. And those forensics are very subtle, as you might imagine, because not all the weapons programs have gotten up to the same degree of sophistication. So you're not only looking for tailings from the manufacturer of nuclear weapons, but you're looking for telltale signs of the technology that might be used for either enriching uranium or coming up with a manufacturing program. And I'll get into a little bit of a recent highlight that we had with the shipment of Libyan material to the site. The other things that we do is we are heavily involved, obviously, in protecting the nuclear materials we have. And a factoid that I know in this room will appreciate is that for every atom of uranium that's ever been enriched to the weapons grade, 60 of 100 atoms resides today at the Y-12 site. We are, in fact, the Fort Knox of enriched uranium. That's a pretty awesome number. I think all of you are aware of the capabilities that we've had at various times in this country for enriching uranium, and it runs into many, many, many metric tons of enriched uranium, and 60 out of every 100 atoms resides today. The balance of them are either in nuclear reactors powering submarines or surface ships for the Navy, in nuclear weapons deployed by our military, or in burial sites because they've been disposed of as unrecoverable waste. So taking those technologies, we can also help in the non-proliferation area by assisting the International Atomic Energy Agency in monitoring and securing those materials around the world. One of the things that we take a lot of pride in is we were the first operating site to ever put material under the control of the International Atomic Energy Agency. We have 10 metric tons of enriched uranium under their aegis at our site, and we have had monthly inspections now for almost 10 years. So in excess of 100 inspections where we open our site and they come in and they do the monitoring activities. And as a matter of fact, our scientists have helped them with a lot of the monitoring activities and the forensics that they use for keeping tabs on the material that's been put under their control. So a lot of the people who actually do this international monitoring are actually trained at our site or have been trained on techniques that are developed at our site. We also have a mission, and it's a pretty burgeoning mission right now, to modernize our site. I mentioned that we're 61 years old as of last month, but one of the things that's happened during that time, and most of that time, is we kept building and building and building. And we still have some of the original manufacturing buildings that were built in the early 40s. And you can imagine with the kind of the philosophy of Manhattan Project that some of those structures were put together rather hastily. We also didn't understand all of the environmental ramifications, certainly the security ramifications that exist today in the world. So we're in the process of modernizing our facilities. That's going to be a multi-billion-dollar investment over the next 10 to 20 years at the site, as we replace buildings that were built in 1953 with more robust buildings from the standpoint of safeguarding the materials, processing the materials, and making sure that it isn't diverted through any surreptitious means. To tell you what the site looks like, everybody shows you baby pictures. Well, there are my baby pictures. The site itself is a little over 800 acres. It's located, as Lee said, about 30 miles from here, perhaps a little shorter as the crow flies. It's about 3 miles long, and it was built in a valley. And in today's security climate, you might wonder why we built it in a valley. It looks for all the world like Little Bighorn rather than Masada. But if at the time it was built, the security meant being a long way from the ocean and in a remote place where you didn't have a lot of traffic coming through. And Oak Ridge certainly fit that bill in the early 40s. We have more than 500 structures and about, now only a little bit over 6.5 million square feet under roof. That's an awful lot of buildings and an awful lot of space to maintain. We have about 6,000 employees that come to work every day at the site. A little less than 5,000 work for me. Of those today, there are about 1,000 degree engineers. And most of those have engineering and scientific positions, but about 200 of our 600 managers also have technical, either engineering or scientific degrees. So we are a large employer of people with engineering education and skills. And that's one of the reasons why we've been as successful as we have been in the past. The detailed way of approaching a problem, scientific method that we've all learned and had drilled into us year after year in engineering education is the thing that makes us premier problem solvers for the world. Our budget this year is going to be a little bit over $800 million, and there's about an additional $100 million that we pay for security. So security is a huge undertaking at the site, and as the slide says, we support about 7,500 retirees. The new mission areas, the place that we're growing into, as I said before, is international control of nuclear materials, international detection of nuclear materials. That has a homeland security emphasis, and certainly we have some premier skills in that area because we safeguard the amount of material and the kinds of materials that we do. But we're also looking at border detection and those kinds of things, being able to detect very small quantities of material. We do that every day at the plant. We not only protect from massive or external diversion, as I think of it, somebody coming in overtly and trying to steal our material, but the covert diversion of the material, a few grams at a time, that could be used to amass enough material to make a weapon of mass destruction. And so those same technologies can be used and applied at airports, at railroad stations, at border crossings, and that's one of the growth areas. And it's pretty exciting work for an engineer. It's kind of the equivalent, or maybe the opposite, of miniaturization. Today we guard very, very compact areas within the plant, very, very controlled ingress and egress. Whereas if we take technologies and deploy them into the field, we would have to have a much higher detectability so that we would be able to protect significant amounts of our borders. I mentioned that recently we had a bit of a media event, and it's rare that we get the kind of public recognition of the things that at Y-12. We happen to be a sister organization to Oak Ridge National Lab, and they've over time gotten into things that have much less security considerations, and so you'll hear a lot about the technology that's developed and the technology that's transferred to industry. We kind of work under the veil of nuclear weaponry, and so it's rare that we have a big media event, so we're kind of proud of this, and you're going to have to bear with me for a couple of minutes while I show you some pictures of my grandchildren here. But what you see before you is a display that we set up a few weeks ago to publicly disclose our participation and the country's participation in the disarming, if you will, or the deproliferation of Libya. Libya had acquired quite a bit of technology surreptitiously, people who were sharing secret technology with them, and recently, the end of last year, decided that for reasons that are political in nature, economic in nature, that they were going to enter into an agreement with our country to divest themselves of that technology. The first shipment of materials and equipment hit here in January, and at that time, and for obvious reasons, the shipments themselves were covert, and the location and the starting place and the destination and the routes were all kept fairly close to the vest. But the administration, the government, wanted to tell people in some real way about what was happening in the world in terms of making some progress. Every day we're bombarded with the terrorist bombings and the people that are killed and the soldiers that are attacked. This is the good side of what's going on in the world, the fact that we're being able to shrink the number of people who really have this very sensitive technology to do things. And so we had this display, and it put a little bit of a burden on us, as you might expect. Inside these crates were not just we didn't borrow these from a play on Broadway. There's real material in each one of these crates, and the materials, other than the ones we were able to show, are all highly classified. And so we moved this whole display into a parking lot outside of the Y-12 site, and so we had to put up some pretty serious security around it because, as Donna would tell you, and she led the effort for us, we had that material out there for the better part of 3 days, and we had to make sure that no mischief done to it. The Secretary of Energy came and was the official that disclosed the whole operation. And you can see here, this was not for show. This is the way our guards are decked out every day. We have special response teams at the plant. There are over 400 uniformed guards, and all of them are armed similar to this particular security police officer. And what he's standing in front of are the outer shells from some centrifuge separation units that are used for the separation of U-235 from natural uranium. We also had a display that included some shots of the actual loading of the materials in Libya and their shipment over here. And as you can see, Zach Wamp, or the congressman who represents the district that our plant is located into, and Secretary Abraham hosted part of the event. And then the last brag is, just so you know that we both worked there. You know, this is a confirmed sighting of Denny Ruddy at the plant. I don't know. I'm not always down here at UT talking to students, but you can see in the background is Mr. Brumley, the man with the bow tie just behind me. He's the head of our local Department of Energy NNSA office, and directly over my head. And he wasn't standing on anything, by the way. He is about 6'10" or 6'11", but he was one of the people that was involved from our end in actually affecting the transfer. So we do some pretty interesting things, and we don't often get a chance to brag, but this was a big event for us, and it was a pretty happy day. Back to the work. We define ourselves still in terms of uranium and the technologies that grew up around uranium, but there are some other interesting things. Most of you have studied enough of nuclear engineering to know that probably the most important thing in succeeding in any application in nuclear engineering is holding very high tolerance. For 25 years, I made reactors for the Navy at the Bettis Atomic Power Laboratory. That's where I cut my teeth in the world. The only reason that those reactors work is because we hold a very, very high precision in all of the things that we do. The amount of water in a reactor in Seawolf class submarines, for example, the tolerance on the amount of water in the fuel region of that reactor is less than 2 ounces. So we hold the total water volume in that space, and the exact length of it and volume of it is classified, but you can imagine for a reactor of that size that powers a Seawolf class submarine, we hold that to less than 2 ounces. So those are the kinds of things that are from a manufacturing standpoint, that are very, very important in the nuclear industry. Similarly, in making nuclear components for a weapon, again, very close tolerances, and you know what the issues are there. Being able to create that predictable mass, critical mass, or supercritical mass is all a matter of tolerancing and engineering to make sure that whole thing comes together. And so one of the things that we do very well is we do very high precision manufacturing, machining at the Y-12 site. We were selected to make the first propulsor for the Seawolf class submarines because we could do two things. We could do high precision manufacturing, and we were also flexible in working with the designers to factor in some of the experimental work time. So two things we're able to do. We're able to work on highly engineered products with very high tolerances, and we're also able to, because we are a very engineering intensive organization, we can do concurrent manufacturing, concurrent design with the designer. And back again to the modernization, we're developing quite some skills in designing and creating new manufacturing facilities for nuclear work. One of the things that you may or may not be aware of is that in industries like the nuclear industry, the government has become very concerned since the beginning of the 90s about the loss of talent, the so-called critical skills that we need to continue our work. And I talked before about craftsmanship versus engineered controls. They become more and more important as we go forward and lose the ability to train people on the job. We have to be able to do it and do it right the first time. And so critical skills is a very important thing. And it's been the topic of many, many reviews by the government to make sure that we don't fall below the brain trust, the size of the brain trust that we need. I hesitate to use words like critical mass in my business, so if I stumbled over that concept a little bit, but we need to be able to maintain that knowledge base, the continuity of that knowledge. And so what we've been very careful about doing is deciding where we can employ engineers, how we can employ engineers, and how we make sure we keep that flow of new people coming into the environment so we have an adequate transfer of knowledge and skills and the experience base beyond just the book learning that people need. So that's what, when we talk about recruiting and we talk about critical skills, that's one of the imperatives in our business. When you get right down to you know, how we use nuclear engineers, I think it's pretty clear from our mission and from the things that we do how nuclear engineers would fit in, you know, at the core of our business. But we also have an awful lot of people who have migrated to our business from other enterprises related to nuclear weapons, and as I shared with you, my background is nuclear power technology, albeit in a military environment, which from a practical standpoint is a much more demanding and exacting business than commercial nuclear technology. Just because you can't afford to refuel and move fuel around in a reactor, when you send a reactor to sea, the fuel stays where you put it the day you manufactured it until you take that reactor out of the submarine or out of the aircraft carrier. And it's no secret anymore, but we are now building reactors that will last as long as the hulls of our ship will last. So you can imagine the nuclear engineering challenges, material challenges that have been taken on and solved the past 25 or so years by the Naval Nuclear Program. But those people tend to migrate into the operation of our facilities. And we use people all the way from the theoretical side. There are many people that work at Y-12 who do theoretical work in terms of nuclear criticality control, the design of equipment for nuclear considerations, the design of equipment for contamination control. But there are also people that work the other end of the circuit too, designing fixtures to hold things and keep them separated from other like materials, calculations for safety. And so we use nuclear engineers and engineers in general across that whole gamut. If you're interested in the very theoretical pursuits, we certainly have those, all the way down to the other end, where if you want to get your hands dirty, we have plenty of opportunities for that too. We try to blend the people's backgrounds and bring in people with commercial power backgrounds, nuclear reactor operators, as well as people like myself that built nuclear reactors, people that were down in the submarines and had to worry about whether or not those things were going to work to get them home, because that blend of different viewpoints is very, very valuable in terms of making our organization come together. I mentioned some of these, but to go back over them again, because we handle such large quantities of material, because we do not only mechanical conversion of uranium, but we also work on chemical conversion of uranium, and we do phase changes and the like. We run the whole gamut of facilities. We have what we call our wet chemistry facilities, where we take material and we change it from various forms into oxide forms and then reduce it back to metallic uranium. And then we have the full palette of metallurgical processes, from initial casting to rolling, and we do microwave casting and melting. So we run the full gamut. We also work with alloys of material, and some of you that have studied some of the nuclear weapons technology know that a wide range of materials in various forms. We do powder metallurgy operations. We do the standard fabrication metallurgy, the full range of chemical testing, because obviously our application is very sensitive to impurities, not only impurities that come along the enrichment process, but we haven't made very much new uranium in a long time. We keep recycling it in and out of the stockpile, and some of the material that's coming out of the stockpile is being reprocessed into reactor fuels, both for downblended for commercial applications, as well as kept up at weapons-grade enrichment for the naval application. And all of the impurities have a different impact depending on the end use of the material. So we have a full range of capabilities in terms of chemical testing, and we are in the process of restarting the very earliest part of our process, where we can, with a series of wet chemical operations, we can in fact take out the chemical impurities. We obviously can't enrichment in any of those processes, but we can change the chemical form, and by doing that we can precipitate out or otherwise dissolve out the impurities that impact the metallurgical characteristics or the lifetime characteristics. Imagine the specification for uranium that's going to wind up in a reactor that could run 30 or 35 years is pretty exacting, because you can't tolerate grain growth and other issues like that in reactor. And then we have a lot of engineers that join us and move on into management positions. And we're very actively making sure that there's parity between the two career ladders, that there are technical opportunities for people as long as they want to stay in what we consider to be individual contributor positions or positions where they work in a team, versus the folks that, like me, at some point in their career, read a book about finance or business development, decide we want to walk up the management chain. So we're very mindful that we maintain those career paths. And as a consequence, being exposed to the kind of program management and project management that we do is very valuable for a lot of our people. We also have engineers that come with us or scientists that come with us that go on and take advanced business degrees, operational research degrees, because they find themselves attracted to those career paths. So where are we? Nuclear engineers. As I think I mentioned before, we've already had 2 acceptances out of the UT School of Nuclear Engineering, and that's very gratifying. Some of you may or may not have been involved in the affair that we had last fall. Yeah, I know you were there, but some of you as students might have been aware of and attended a little dinner that we had, and we talked a little bit about Y-12 at that time also. Our association with UT is one of our most valued partnerships. A highly technical organization needs the credibility of being associated with a high-powered higher education, and UT is that, and it satisfies that very essential need for us to have that association. We support scholarships here, and we're very active trying to come to arrangements for co-op opportunities as well as internship opportunities. And in any given year, probably have between 60 and 100 co-op and intern opportunities, and I think they're very valuable. We see them as highly valuable because when we form an association with a student, often that association continues. They feel pretty good about us, we feel pretty good about them, and want to continue that into a full-time employment opportunity. But if you've not had the opportunity to do that, we certainly want to talk to you about full-time employment as you reach the end of whatever educational experience you happen to be involved in, a bachelor's degree or any kind of advanced degree, or if you're going to take time out and get an MBA before you hit the street, then that's a powerful combination. So, what I'd like to leave you with is we have a highly technical organization. It is mainline nuclear engineering with a lot of considerations in the materials side. We employ every conceivable kind of engineer but certainly nuclear engineering and the future in nuclear engineering, we see ourselves as one of the supporters, the users of the educational experience that people get all over the country. So thanks for having me here today, and thanks.
Okay, we do have time for questions and comments. Larry?
Can you share where those substitutes were made that Linda had?
No. But I think if you read the newspaper enough, there are enough clues.
Okay.
You know, to answer that in a slightly different way, it's important for us to understand the level of sophistication that the world is at. And so one of the things when I talked about forensics is tracing the materials that those things are made at, their real. We can tell from the metallurgy of the various materials where they were made initially, and we can often tell where those things were manufactured by some of the telltale signs. So one of the reasons that we want them, and we just don't destroy them in place to kind of erase the technology, is to kind of trace where different organizations are around the world in terms of the maturation of the technology.
I didn't figure it out from reading, but I was curious to know whether it was our friends or enemies or both that were making those for them.
Well, you know, the definition of friend and enemy changes so often. It's almost a moot point.
Other questions or comments?
Yes, sir.
Several years ago, you had a program for graduate studies. You always had a good educational assistance program. There was a program whereby persons that were elected doing a master's or a PhD, their full-time jobs.
I don't believe we have anything like that currently. Those kind of programs have fallen into disfavor with the government. You know, the government overall views the effectiveness of these programs and the value of these programs kind of in personal terms. And so anytime there's an abridgment of the things that are available to federal employees, it tends to wash over the wall into the contractors. So I don't believe we have anything like that. But there is a program that's not exactly like that we're starting up, talking to folks here at the UT School of Engineering. And that is a program whereby we would offer first to our own employees or to our summer interns or co-op students some hands-on education, things that might not be available at the university, to try to get the tactile side of engineering education back to where it might have been 20 or 25 years ago. One of the things I often reflect on is the fact that a lot of my engineering was learned lying under an automobile outside the apartment that I lived in, keeping it running so I could go out on a date on Saturday night. But I dare say that I would be reluctant to put a wrench on anything under the hood of my car today because I'm afraid I broke it and I wouldn't even know it was broken. So we've lost some opportunities for getting engineers into the thought process of engineering before we educate them. And there's a lot more of the education that's computer-oriented, and that's very valuable. When the people with those analytical skills and the use of those tools come into the workplace, they're very, very valuable in one sense, but they've lacked something in the other. I mean, there are anybody in this room other than Graybeard, anybody ever sat at a drafting board? Couple. Okay. It's a whole lot different than CAD CAM. Okay, I can tell you that right now. I mean, I remember being graded in high school and then again in college, flipping my lines, and you know, and whether you showed construction lines or didn't show construction lines, and you get in touch with the things that you do a little bit differently. So we're starting a program, and we're going to start our first class in May, and it's going to be part of our new engineering training orientation, but eventually we're reaching out to the universities and maybe someplace down the line actually getting those sequences accredited so that we could join the educational experience for a lot of students. So it's not quite what you talked about, and you know, I had friends at Westinghouse in the early 70s went on there 2-year sabbatical and got their PhD, and they drew a salary against that, and it was a powerful program. Just you can't get the support for those kinds of things anymore. You had a question.
Yeah. The material surveillance techniques that you referred to, are they being used for inspecting commercial cargo?
For the most part, the inspections that are done for commercial cargo are still in experimental stage, but there are companies in Oak Ridge, SAI is one of them, and there are some other companies in Oak Ridge that are working on these massive surveillance techniques. Be able to put up a portal, and as trucks drive through but at a reasonably slow speed, 15 or 20 miles an hour, you would be able to see if materials, radiological materials or other contraband kinds of materials are secreted inside the containers. These are going to be very valuable in sealing our ports around the country. Some of them are in use, but mostly on an experimental basis. Right. Today, our most effective sentinels are explosive dogs, unfortunately, and drug dogs, and we're trying to move on that with the application of technology. Yes, sir.
Given your expertise in uranium, are you also part of monitoring what the Russians have and how they are, whether they have control over the uranium, or is that some other entity?
Yes. Y-12 is one of a number of places around the country that provides the expertise as well as the people themselves to interact with the Russians on the repurchase of uranium. We at Y-12 have been involved in every repurchase of uranium from Russians, and that's an outlet for our technology, because one of the things we're most concerned about, obviously, transporting these things. And so we're working on portable downblending technology, portable storage technology, used almost situ when we're offered a cache of uranium to actually put it in a form that's not quite as susceptible to proliferation. So yeah, we're involved in very actively in the Russian program.
I have a question. You mentioned interns and co-ops.
Yes.
And I know the security concerns of Y-12. How do you address giving these, I think you said you had about 60, giving them meaningful work, but yet not going through the 20 months to provide Q clearances?
Well, certainly the greatest advantage would be a long-term kind of relationship. If we get somebody at the end of their freshman year or at the end of their sophomore year, we can start the clearance process because, in fact, they're connected to us, and that would be a tremendous advantage. By the time you got to the point where you got your bachelor's degree, you'd have your clearance and you could come immediately aboard. Now, the other question, excuse me, is how do we engineers gainful employment? You know, the unfortunate part of it is you're not going to get to see the icon until you get cleared. But there's a lot of interesting engineering work going on at the site every day. And what we do is the interns, we bring them in, we put them on simple tooling design and things that they don't have to have access to classified information. But there is a lot of interesting work done without possessing a security clearance. So the first time you're associated with us, you'll probably work 12 or 14 or 16 weeks, a little bit longer in a work period and not have a security clearance. But typically students are the easiest to get cleared because you haven't been in as much mischief as some of us old-timers. You know, you haven't been overseas military or overseas traveling or on exchange programs, whatever, like some of the professors might be. So the clearance process is generally more straightforward for young folks that don't have as big a dossier as some of the old ones. But it is an advantage. I mean, if you have the idea that you want to have a long-term association with Y-12 or any other place, Los Alamos or whatever, you might might pursue that route of becoming an intern, becoming a co-op, so that you can get that behind you before it's time for you to be involved in some meaningful work.
Okay. If there are no further questions or comments, let me remind everyone that we do have refreshments downstairs, and everyone is indeed invited. But before we adjourn, let's express our appreciation. Very much. Excellent.
Thank you, sir. Had a good time?
Yeah. We'll get this clock. Next time you come, there'll be one there.
Yeah, well, it wasn't too bad watching my watch.
Yeah.
8,000, you're welcome.
See you again.
Number here.
Glad you're doing good.
I've worked kind of with Y-12 on a few things. I'm finishing up a project out there. But last year, we had what's called a partnership technology.